Curiosity stumbles upon an ancient stream bed, takes some spooky images during the night, and finds bright particles on the Martian surface. August 6, 2012. The Mars Reconnaissance Orbiter happens to be in the right place at the right time to capture this incredible image of the Curiosity rover parachuting onto the surface of Mars. After a nerve-wracking but successful landing, Curiosity opens its eyes. It will eventually start to climb the mountain in the distance, which is informally known as Mount Sharp. For now, however, the rover will drive away from Mount Sharp towards an interesting region known as Glenelg. Just 13 Martian days into the mission, or Sol 13, Curiosity examines a site that was blasted by the engines of its descent stage. Nicknamed Goulburn Scour, these sedimentary rocks are thought to have been laid down by running water in the ancient past, and uncovered by the descent stage as it blasted away the surface dust. On Sol 16, Curiosity takes a close look at the layers which form the base of Mount Sharp, with scientists theorizing that these layers could be another clue of a watery past. On Sol 27, Curiosity comes across a site which again could be linked to running water. This image shows what is known as a sedimentary conglomerate, a geological formation that is created by streams or rivers here on Earth. The engineers at NASA check the health of Curiosity's wheels. They look to be holding up pretty well so far. On Sol 39, the rover comes across yet more evidence of a Martian stream. This is a piece of exposed bedrock, made up of small segments cemented together. This is likely evidence of ancient water due to the rounded elements of the bedrock itself, as well as the round rocks and pebbles surrounding it. It's possible these rounded rocks were transported and deposited here by running water. If finding 3 sites likely formed by running water wasn't enough evidence, just look at how they are arranged. The yellow arrows at each site depict the direction of the ancient stream. While this map shows the route the rover has taken so far, Curiosity turns around to once again take in the sight of the mighty Mount Sharp in this incredible mosaic. Climbing the mountain will be hard, but worth it in the end. Curiosity comes across an interesting pyramid-shaped rock and decides it's a good time to test out its onboard laser. In this image, the dots are where Curiosity trained its laser, and the results are unlike anything yet seen on Mars. The rock has a mineral diversity down to the finest scales and is very similar to a rare but widespread rock type found on Earth. On the road to Glenelg, a site known as Rock Nest is selected for the first use of Curiosity's scoop. The patch of sand downhill from the cluster of dark rocks should make for a great scoop sample. At the site, the rover comes across an interesting rock. It's not clear what has caused the thin cavities present in the rock. On Sol 61, Curiosity makes its first scoop. Darker colored sand is exposed just beneath the surface. The sample will now be shaken and put through a filter. This series of images shows the shaking operation. This makes sure that the sample scoop is not overflowing with material and allows the scoop to be sealed shut. This image shows the filter. After the shaking operation, any particles too big to pass through this filter are transferred back to the scoop for a visual inspection. Those larger particles can be seen here. This first sample will not be fully processed, as its presence in the scoop helps to further decontaminate all the surfaces coming into direct contact with future samples. On Sol 65, the team at NASA spots an interesting piece of debris on the Martian surface, just next to the rover. This close-up confirms it is likely to be from the spacecraft, possibly as a result of the landing. It is likely a benign piece of plastic or shrink tube left over from a terminated piece of wire. As Curiosity takes its second scoop, a bright particle can be seen in the sample hole. Given that spacecraft debris has been identified in the area, the team at NASA orders the rover to also discard the second sample. If any of these bright particles are from the spacecraft and are subsequently fed into the internal sampling unit, the rover could become contaminated with bacteria from Earth. However, upon further inspection and analysis, more bright particles are spotted on the ground, and the team now believes these are native to the Martian soil. It is likely these bright particles are made up of silica or some other naturally occurring mineral. With this knowledge, the rover goes ahead and takes its third scoop, which is fully processed. The result of the soil sample shows that about 2% of the material collected is made up of water. The rover exposes the sample to heat. Carbon dioxide, oxygen, and sulfur compounds are released. To celebrate, the rover takes a little break from sampling and captures this stunning panorama of the rock nest area. Curiosity will continue on to Glen Elg. On Sol 120, the rover comes across a site nicknamed Shaler. The Shaler outcrop is dramatically layered, once again signaling the presence of water in the ancient past. This part in particular, known as sheepbed locality, shows well-defined veins filled with a whitish material likely to be calcium sulfate. The rover reaches a wider area known as Yellowknife Bay and takes a look around. In this annotated image, the white arrows represent mineral veins and the black arrows represent mineral concretions. Both veins and concretions are strong indicators of mineral precipitation from water. A target is chosen for the first use of Curiosity's drill, a drilling site known as John Klein. This flat, hard bedrock should provide an ideal testing ground. As the engineers at NASA prepare for the first drill, Curiosity spots a small, broken rock nicknamed Tentina. Curiosity deploys its mast cam to perform a spectra analysis and produces a mineral hydration map. The results show the inside of the rock is much more hydrated than the outside. The team orders Curiosity to pull an all-nighter. These are the first nighttime images from the surface of Mars. The team wants to see what the rocks look like under UV lighting to see if any fluorescent minerals are present. Unfortunately, this image taken under UV lighting doesn't show much evidence for fluorescent minerals. If they were present, we would see bright red, blue, or orange areas. On Sol 174, Curiosity breaks a rock in half by driving over it. A happy accident. Curiosity's clumsiness reveals a very bright substance within the rock. This is probably caused by the presence of silica, commonly found on Mars. Curiosity takes a selfie before its big drill test at the John Klein site. The drilling goes ahead and is a great success. The drill sample is transferred to the scoop, which will feed the sample into Curiosity's internal sampling system. On Sol 200, Curiosity stops responding to commands. Engineers fear Curiosity is stuck in a boot loop, which will cause the rover to drain its battery and be unable to function. Luckily, Curiosity has two computers on board for such a problem, Side A and Side B, or pilot and co-pilot. The rover is programmed to switch to the co-pilot automatically if the pilot malfunctions. However, the pilot has other plans and does not cede control to the co-pilot. The engineers are worried that the pilot could shut off the radio at any moment and they would never hear from the rover again. They decide to take a risky move and shut down the pilot, hoping that the co-pilot will then step in and take over. After shutting down the pilot, the team waits to hear a signal from the co-pilot, which should happen right away. 1 minute passes, no signal. 4 minutes pass, still no signal. Then finally, the signal comes in, and it's clear that the co-pilot is now in charge. Curiosity can breathe a sigh of relief and continue with operations. Now that the rover has switched over to the B side, the team must check all the systems once again. Now that everything is working as intended, Curiosity takes a long drive. This image, taken on Sol 343, shows the road before Curiosity. The two gray rocks in the center are nicknamed twin cairns. Curiosity sees a mysterious light on the horizon, spots Earth in the sky, and crosses Dingo Gap, a perilous sand dune. Curiosity is now en route towards the central peak of Gale Crater. To make the journey easier, Curiosity has the ability to drive itself with no help from anyone on Earth. This enables faster progress, which means Curiosity is already closing in on an area dubbed Darwin. The light-toned streaks in the lower left center of the image mark the position of the outcrop that scientists want to examine. Curiosity takes another look at the layering making up the base of Mount Sharp from its new vantage point. This area looks particularly exciting and is named Parumph Hills. The team hopes to explore this area soon. On Sol 400, Curiosity examines the Darwin outcrop with its Mars Hand Lens Imager, or MALI for short. This 4-image mosaic shows a ridge, formed when a crack in the underlying sandstone which was filled with a material that then eroded more slowly than the rock itself. Note the Lincoln penny at the bottom left, Mali's own unique calibration target for scale. While studying this rock named Ithaca, the rover's ChemCam laser is fired for the 100,000th time on the Martian surface. The arrows point to the dark spots left by 10 different laser shots. Analysis shows Ithaca to be a typical Martian volcanic rock type. As Curiosity reaches nearly 3 miles of driving, life on Mars begins to take its toll. Further computer glitches are followed by a loss of power, which temporarily strands the rover. This is tracked down to an intermittent short in the RTG, Curiosity's nuclear power source. At the same time, an even more serious issue arises. A routine scan of the rover's wheels on Sol 469 shows unexpectedly heavy damage. According to Jim Erickson, Curiosity project manager, we always expected we would get some holes in the wheels as we drove. It's just the magnitude of what we're seeing that was the surprise. Concerned, the team modifies Curiosity's planned route, trying to drive on smoother, sandier terrain. The trip to Mount Sharp will be longer, but hopefully safer for the rover. As part of the new route, Curiosity comes across a target named Harrison, which contains light-colored elongated crystals, most likely a mineral known as feldspar. Analysis using ChemCam shows the darker matrix material to be pyroxene, a mineral typically found in basaltic igneous rocks. On Sol 526, Curiosity faces another challenge. The modified route to Mount Sharp means crossing this sand dune, known as Dingo Gap. It will open the way to smoother terrain, which should be easier on the rover's battered wheels. But there's a danger the rover could become permanently trapped, like Spirit, its predecessor on Mars. While the engineers at NASA prepare to cross Dingo Gap, Curiosity is stargazing. Just after sunset, the rover captures a Martian evening star, otherwise known as Planet Earth. Look closely and it's possible to see our moon too. On Sol 535, Curiosity begins to cross Dingo Gap. As this view from the rear hazard avoidance camera shows, with 6x6 drive, a little off-roading proves no problem at all for Curiosity. Curiosity looks back at its tracks across the perilous gap. To give you an idea of scale, the distance between the parallel tracks is about 9 feet or 2.7 meters. After crossing the gap, Curiosity makes good progress and is aiming for an area named Kimberley. On the approach to Kimberley, Curiosity spots these sandstone beds tilted down toward Mount Sharp from the rim of Gale Crater. The team interprets these layers as deposits from deltas flowing down from the rim into a small lake that once covered the center of the crater. It's a pattern that's repeated throughout the area. On Sol 589, Curiosity captures something that shocks scientists: a glowing light in the distance. The bright light puzzles scientists. Possible explanations could be a cosmic ray hit on the camera, or something as simple as sunlight glinting off a rock. But unless Martians wear tinfoil hats, it probably isn't our first sighting of aliens. The most likely explanation is a cosmic ray hitting the camera. Cosmic rays are high-energy particles that fly through space. This is the most likely explanation, because another image was taken with a different camera at the exact same time, which did not capture the strange anomaly, or in other words, wasn't hit by that same cosmic ray. Even astronauts working in space have reported seeing strange flashes of light with their own eyes, which are also believed to be cosmic ray hits. When a cosmic ray passes through the retina, it causes the eye's rods and cones to fire, and the eye perceives a flash of light that is really not there. Thankfully, here on Earth, we are protected from cosmic rays by our magnetosphere. However, Mars has a much weaker magnetic field. Future Martian settlers may just have to accept and deal with strange pseudo-lights caused by cosmic ray hits. With so much great science, investigations at Kimberley continue for some time. This image taken on Sol 590 shows the same build-out of ancient sediment towards the base of Mount Sharp, with the mountain itself towards the left of the scene. Also, a small hill can be seen in the midground. So clear are the different layers of rock that the team dubs this site Mount Remarkable. On Sol 597, NASA's Mars Reconnaissance Orbiter is flying overhead and manages to capture Curiosity near the Kimberley site. Can you spot the rover? On Sol 609, Curiosity arrives at a rock slab that scientists called Winjana. The 2-foot-wide rock looks like a perfect target for Curiosity's drill. As these before and after shots show, an area of the rock around 6 centimeters across is scrubbed using the dust removal tool, followed by test drilling to a depth of around 2 centimeters, and a full-sized test hole. The series of dark dots which are visible inside the hole were created by Curiosity's ChemCam laser. The samples obtained are examined by several of Curiosity's onboard scientific test instruments. The results are analyzed by researchers back on Earth and point to the likelihood that flowing water was once prevalent in the area. Pleased with its work around Kimberley, Curiosity poses for a selfie. On Sol 648, Curiosity is looking at the Sun and manages to capture something remarkable, an object crossing its field of view. This object is actually the planet Mercury, and it's the first time a planetary transit has been witnessed on a planet other than Earth. As this map shows, by Sol 705, the rover is well on its way toward the Pahrump Hills at the bottom left. The new route designed to make the journey easier on Curiosity's wheels will take the rover through a valley aptly named Hidden Valley. However, this new soft-sanded route doesn't come without problems. After driving only a short distance into the valley, the rover's wheels seem to be slipping on the ground, and the team starts to worry that the rover may become stuck. Rover planners decide it's too risky to continue, and so order Curiosity to leave the valley and head back to more stable ground. Curiosity escapes Hidden Valley, explores a site named Garden City, and witnesses the Martian sunset. The rover is currently located in a valley with soft, deep, and slippery sand. The team at NASA wants to get out of the valley as soon as possible, as Curiosity could become stuck. This series of images from the rear HazCam shows the rover backing out of the valley, retracing its tracks. This is the view from the other side of the rover, the front HazCam, as the team initially sent the rover in backwards, a strategy used to compensate for the poor health of Curiosity's wheels. Now, safely out of Hidden Valley, Curiosity is finally approaching the Pahrump Hills. The team decides to take a drill sample at this site, known as Confidence Hills, as the rocks nearer to Mount Sharp will help to develop a picture of what happened in this area. Here is the sample in the scoop. On Sol 801, the team decides to perform an experiment by driving over a sand ripple to expose the material below. The reason for this experiment is to gain a better understanding of the loose, wind-deposited sand ripples in the area. Hopefully, more knowledge about these deposits will prevent future situations like the one at Hidden Valley. The wheel track provides a cross-section view of the sand deposit, and Curiosity uses its laser to take data. On Sol 817, Curiosity comes across some interesting exposed bedrock and takes a close look. The area is about 6 feet or 2 meters across. Meanwhile, the Mars Reconnaissance Orbiter is flying overhead and spots the rover, now squarely within the Pahrump Hills area. Curiosity is ordered to perform a drill test on a target named Mojave. The result is a cracked rock. On Earth, geologists carry hammers to crack rocks. This apparent mishap presents a rare opportunity to see freshly exposed rock on the Martian surface. Curiosity is ordered to take 2 drill samples from the same site. No further cracking is observed. The rover celebrates by taking a selfie. This map shows an area named Artist's Drive, which Curiosity will have to pass to access higher rock layers on Mount Sharp. On the way, the team at NASA spots an interesting outcrop, which is named Garden City. Exposed mineral veins crisscross the entire area. Curiosity heads over to take a closer look. Mineral veins usually form where fluids move through fractured rocks, depositing minerals in the fractures. In this case, the minerals deposited in these veins have been more resistant to erosion than the surrounding host rock. The contrast between the light veins and darker rock type here suggests a very high fluid pressure. This image covers an area roughly 2 feet or 60 centimeters across. The Mars Reconnaissance Orbiter spots the rover once again within the Artist's Drive site. Can you spot it? This interactive map made by NASA shows the true scale of the journey. Zooming out from the Pahrump Hills area, we can see the size of Gale Crater as well as Mount Sharp in the center. Gale Crater is roughly 96 miles in diameter or 154 kilometers. Curiosity stops to take a panorama within Artist's Drive, now well within the Pahrump Hills region. This mosaic shows the view in front of the rover. Gravel and sand ripples can be observed in the foreground, typical of terrains that Curiosity traversed to reach Mount Sharp from its landing site. Outcrops in the midfield are of 2 types: dust-covered, smooth bedrock that forms the base of the mountain, and sandstone ridges that shed boulders as they erode. Rounded buttes in the distance contain sulfate minerals, perhaps indicating a change in the availability of water when they were formed. On Sol 956, Curiosity captures multiple images of the Martian sunset. This short series of images provides the most detailed view of what a sunset looks like on Mars. As Curiosity continues, it approaches an area nicknamed Logan Pass. This closer image shows that this terrain is unfavorable for the rover. Instead, the team decides to take Curiosity through a safer passage known as Marias Pass. On its way through, Curiosity observes what scientists are calling the Stimson Unit. These dark areas of finely bedded sedimentary rock are found throughout Gale Crater and make up the Stimson Unit. Here, the lighter-colored mudstone is intersecting below the Stimson unit, leading the team to conclude that the mudstone was created first, and then a large body of water-deposited minerals that make up the layers of the Stimson unit. This image of another contact zone at Marias Pass, nicknamed Missoula, lends further credence to this theory, as the white mineral veins abruptly end where they meet the darker rock above. So firstly, the mudstone would have hardened, then fractured, and then groundwater-deposited minerals to form these veins. Sometime after that, large bodies of water made the layers visible at the top. Just a few days later, on Sol 1041, Curiosity comes across another interesting rock, which is thought to have been formed by the wind and contains a large amount of silica. Rocks containing silica are known to be exceptionally good indicators of ideal conditions for preserving ancient organic material. The team at NASA orders Curiosity to examine the health of its wheels. During this process, a rock can be seen hitching a ride inside one of the wheels. The rock should prove to be no danger to the mission and will eventually fall out on its own. Although showing a lot of damage as well as some rather large holes, the wheels are okay for now. The rover is ordered to take a rock sample from a site known as Buckskin and celebrates by taking yet another selfie. Curiosity explores a giant dune field, takes some stunning images, and approaches the entrance to Murray Buttes. Still squarely within the Pahrump Hills region, Curiosity finds more evidence of cross-bedding. Due to the angles of these layers, it's more likely they were created by wind rather than water. On Sol 1099, the rover looks toward its main objective, Mount Sharp. The lighter-colored rocks in the distance are the oldest in this image and have been heavily eroded by the wind. A large portion of the other rock variations present are thought to have been formed by water. While looking for the best way to get up the mountain, the Mars Reconnaissance Orbiter spots a huge dune field. The team at NASA decides to send the rover to investigate. From its current position, Curiosity can see part of this dune field, the dark band in the midground. The team at NASA gives it the informal nickname, the Bagnold Dunes, named after Ralph Bagnold, who crossed the Libyan desert and was one of the first explorers to acquire a deep understanding of the physics behind sand dunes. In this map, we can see the true scale of the Bagnold Dunes. Curiosity will explore only a small portion of it. As the rover moves closer, it captures this stunning image, with Mount Sharp looming in the distance. But first, Curiosity has some drilling to do at a site named Big Sky. The rover takes a selfie in celebration of a successful drill. On Sol 1176, Curiosity reaches the edge of the dune field. This is the first active dune system studied up close on another planet. Scientists observing the dunes estimate they are migrating by about 1 meter per year due to action from the Martian wind. The rover carefully dips a wheel into the sand. This close-up image of the dune portion disturbed by the wheel shows finer grains of sand below the surface. This close-up shows an undisturbed portion of the dune. We can see that only coarse surface material remains, after wind action has removed the smaller particles. On Sol 1197, Curiosity comes across a very steep dune which the team names Namib Dune. The thing which differentiates dunes from the usual sand deposits, such as those the rover was nearly stuck in at Hidden Valley, is that dunes are steep enough on their downward face that material can actually fall down the side of the dune. Curiosity takes a sample of sand from near the Namib dune site and takes a selfie to celebrate. The coarse material from the sample, which was too large to fit through the rover's filter, is dumped onto the ground. The team waits until nightfall to take an image of the dumped material with artificial lighting. This lighting makes it easier to differentiate between the darker and lighter grains. Curiosity continues the journey up the base of Mount Sharp, reaching a site known as Naukluft Plateau. On Sol 1276, Curiosity comes across some knobbly textured sandstone within Naukluft Plateau. These nodules seem to be more resistant to wind exposure than the surrounding host rock. It's the first time Curiosity has come across this type of pattern in Gale Crater, but it has been spotted by previous rovers on Mars. It's likely these are what the team at NASA refers to as blueberries and are made up of a mineral known as hematite, which suggests the presence of water in the ancient past. From its position within Naukluft Plateau, the rover takes a long-distance image of the northern rim of Gale Crater. The image is taken during sunrise, when dust in the atmosphere is relatively low. On the lower portion of the crater rim, we can see valleys, channels, and debris fans, much like what we currently see at the base of Mount Sharp. This leads scientists to expect that the entire crater was once filled with water. Curiosity takes a full-circle panorama at Naukluft Plateau. The rocks present here are dominated by thick layers of wind-blown sand, suggesting that these deposits formed during a drier time on Mars. On Sol 1315, NASA orders the rover to complete a wheel health check. Since the last wheel check, nearly 300 sols ago, little further damage is observed, meaning that the rover planners are doing a great job of selecting easier terrain for Curiosity. As Curiosity comes close to completing 4 Earth years on Mars, it hits a milestone of 2 Martian years studying the planet. During this time, Curiosity has been studying Martian seasonal patterns. As you can see from the graph, Mars is much colder than Los Angeles. The height of the bars represents the temperature difference between night and day. During the summertime in Gale Crater, daytime temperatures can reach a survivable -10 degrees Celsius or 14 degrees Fahrenheit. However, on the very same night, temperatures could drop all the way to -70 degrees Celsius or -94 degrees Fahrenheit. Curiosity also takes measurements of atmospheric pressure. This data will prove to be extremely useful if NASA ever wanted to send a helicopter to accompany a future rover. The rover takes a drill sample at Naukluft Plateau and looks toward Mount Sharp. We can also see some leftover rock powder, the gray substance on the surface, dumped by the rover after it did not pass through the filter. After a big drive, Curiosity arrives at the gates of a site known as Murray Buttes. Curiosity will pass through here to access higher areas of Mount Sharp. Curiosity explores some giant mesas, finds a Martian meteorite, and captures multiple dust devils. Curiosity is closing in on the Murray Buttes site, informally named after planetary scientist Bruce Murray, who was a former director of NASA's Jet Propulsion Lab in Pasadena, California. The 2 most prominent mesas in this image are about 260 feet or 80 meters apart. The mesas are about 33 feet or 10 meters high. The buttes and mesas here are thought to be eroded remnants of ancient sandstone created by wind-blown sand after lower Mount Sharp had formed. They are capped with material that is relatively resistant to erosion, giving them a top-heavy appearance, as is the case with many buttes and mesas here on Earth. The rover gets a view from a different position. The relatively flat foreground is part of what scientists are calling the Murray Formation, which includes ancient lakebed mud deposits. We've seen this formation in previous episodes and examined how it interacts with the Stimson unit, made up of darker layered deposits. Curiosity moves closer to one of the buttes, which is given the affectionate nickname Butte M9A. It stands at about 16 feet or 5 meters above Curiosity. On the left side of the butte, the average slope is estimated to be at about 40 degrees, while the right side is less steep at about 30 degrees. The rover takes a step back to get yet another view of this scenic area. It will now pass through the buttes. The rover takes 5 incredible close-up images on its way through. The thin layers here are evidence that this area was created by wind action and sand dunes. This is known as cross-bedding. The angles of some of the layers also give this indication, as water-based deposits tend to be more level. Now, almost safely through the buttes, Curiosity takes a drill sample and celebrates by, you guessed it, taking another selfie. On Sol 1505, Curiosity comes across a very strange rock. Using its laser, the rover confirms the rock to be an iron-nickel meteorite. The shiny white spots you can see on the rock are due to the laser pulses, and the meteorite is around the size of a golf ball. Curiosity looks toward the higher elevations of Mount Sharp. These annotations give a sense of distance and scale. On Sol 1555, the rover stumbles upon a portion of the Murray Mudstone Formation, which shows what could possibly be ancient fossilized mud. This small grid of polygons could have originated as cracks in drying mud over 3 billion years ago. The area is given the nickname Squid Cove. The polygons are around 1 to 2 centimeters or half an inch to an inch long. Another rock slab in the area showing the same type of pattern is observed. It's given the nickname Old Soaker. Curiosity drives to get a closer look. This pattern would have been created by a 3-step process after ancient Martian mud dried out, causing it to crack. First, wind-blown sediments filled the cracks. Second, the sediments and mud became rock under the pressure of younger layers accumulating above them. Lastly, after the younger layers were removed by the wind, the sedimentary areas remained, being more resistant to erosion than the mud, causing them to appear as ridges now instead of the cracks they originated as. On Sol 1587, Curiosity takes a break from driving. The team picks up the next day where they left off and sees that the sand beneath the rover has moved. This constant action from the wind is responsible for a lot of the rock formations and dunes we've seen so far. The area pictured beneath the rover is around 3 feet or 1 meter across. It's summertime in Gale Crater, and Curiosity spends the next few days observing dust devils. These dust devils are created by the sun heating up the surface, causing convection currents as hot air rises, carrying dust with it. They are most active in the Martian summer, as they are here on Earth. In this recording, we can see the dust devil disappear over a hill in the distance. In reality, the dust devils are moving much slower, as the images making up this sequence were taken in intervals of 12 seconds. On Sol 1598, Curiosity reaches a strange-looking hill. It's given the nickname Ireson Hill and stands about 16 feet or 5 meters high. Nearby is a large dune field. It's given the informal name Nathan Bridges Dune, in memory of the planetary scientist Nathan Bridges, who was leading the Curiosity team's Dune campaign. On Sol 1641, a wheel check shows a break in the raised tread on one of Curiosity's wheels. These raised treads are called grousers, and testing with identical wheels on Earth shows that when 3 grousers have broken in any one wheel, the wheel has reached around 60% of its useful lifespan. Fortunately, the slow rate at which the grouser's condition is deteriorating means Curiosity can continue for quite some time. Other images taken during the wheel check show a slight increase in the number and the size of holes present. On Sol 1647, the team spots part of an active sand dune that contains features not seen back here on Earth. The dark-crested ripples are several feet apart, and this particular mix of medium-scale ripples, along with the smaller-scale ripples, are, as far as we know, unique to Mars. The area is given the nickname Ogunquit Beach. Curiosity's planned route will take it over a large ridge known as Vera Rubin Ridge. The mineral hematite had been identified on this ridge by the Mars Reconnaissance Orbiter well before Curiosity's landing, and it has always remained a target of interest. The rover is now approaching the ridge. As Curiosity gets closer, the layered deposits making up the ridge become clearer. The rover will now begin to climb up the ridge. As this map drawn up on Sol 1750 shows, the Vera Rubin Ridge climb will give Curiosity access to special areas higher up Mount Sharp, such as the clay and sulfate units. The yellow line beyond Vera Rubin Ridge shows the proposed route. As the 5th year of Curiosity's mission draws to a close, the rover is watching out for Martian clouds. The 8 images in this sequence were taken over a span of 4 minutes. The clouds are similar to cirrus clouds on Earth, likely composed of crystals of water ice which condense onto dust particles in the thin Martian atmosphere. Curiosity climbs up Vera Rubin Ridge, finds what some scientists believe to be fossils, and survives a global dust storm that permanently incapacitates another NASA rover. You may have noticed that Curiosity hasn't taken a drill sample for quite some time. This is because the last time the rover attempted this in December of 2016, a key part of the drill stopped working. The rover arm was originally designed with 2 finger-like stabilizers within which the drill bit extends and retracts. A faulty motor stopped the drill extending past the stabilizers, and the team has been looking for a fix ever since. On Sol 1780, the team at NASA manages to get the drill out to its fullest extension, 110 millimeters, and now plans to bypass using the stabilizers altogether. This would be similar to freehand drilling, such as when people drill into the walls of their home. This new technique is named feed-extended drilling, and NASA scientists will have to hack into the rover's other capabilities, such as pressure sensors on the rover's arm, to be able to do this successfully and safely. Curiosity is approaching Vera Rubin Ridge. The horizontal stratification of the rock coupled with the crisscrossing white veins are indicators of fluid flow through the rock. This ridge will make a great target to test the new drilling method. The rover edges closer. The team at NASA decides to deploy Curiosity's dust removal tool on a nearby rock. First, the dust removal tool is inspected for damage. The wire bristles are spun at 10,000 revolutions per minute for a duration of around 60 seconds when removing dust. The wire bristles seem to be holding up well, and the rover is ordered to proceed. The brushed area is around 2.5 inches or 6 centimeters across. The purple tint signals the presence of hematite. The area is nicknamed Christmas Cove. When applying Curiosity's science camera filters, the presence of purple-toned hematite is undeniable, signaling the presence of water in the past. The white veins are believed to be calcium sulfate minerals, also caused by the flow of water. On Sol 1856, the rover reaches the top of Vera Rubin Ridge. The view from here is incredible. The slopes in the distance make up the northern wall of Gale Crater, and Curiosity's landing site is also visible. The rover is really starting to gain some elevation as it heads up Mount Sharp. At the top of Vera Rubin Ridge, the rover comes across some strange, stick-shaped features. They are about 5 to 10 millimeters long, or about the size of a grain of rice. Some scientists believe these could be ichnofossils, a record of biological activity in the past, but not direct fossilized remains of an animal or plant. They argue that nothing like this has ever been seen on Mars before. They are concentrated in this area, and they resemble trace fossil burrows back here on Earth. What makes this even more compelling is that Vera Rubin Ridge could very well have been an ancient shoreline. The rover planning team gives Curiosity some more time to investigate with its ChemCam instrument. However, it fails to gather any usable data. NASA believes these features are simply fracture fills that are more resistant to erosion, which have broken up to create these small, dark sticks. What do you think? Leave your theories in the comments below. Curiosity comes across a staircase-like feature atop Vera Rubin Ridge. The layering of the rocks up here really interests the team at NASA. The rover turns its focus towards Mount Sharp. The area in the midground is believed to contain large amounts of clay. This map shows the journey thus far. The rover has made it over the Bagnall Dunes, up onto Vera Rubin Ridge, and is making good progress up the base of the mountain. Curiosity takes a selfie at its current location on Vera Rubin Ridge. The team at NASA wants to test the new drilling technique here. On Sol 1956, the rover performs a partially successful drill using the new so-called freehand method. At just 2 centimeters, the depth isn't enough to enable Curiosity to process the sample, but it's a step in the right direction. On Sol 2057, the team orders Curiosity to attempt another drill at a site named Duluth. This time, at a depth of 2 inches or 5 centimeters, the drilling is a complete success. This is the first drill sample taken in over a year, and the team at NASA is ecstatic. Curiosity's drill is back online, and this proves that the new technique, feed extended drilling, can and does work. While the rover is happy with its success, the Mars Reconnaissance Orbiter is circling the planet overhead and detects a dust storm starting to grow in size. The sample is transferred successfully into the sample inlet using a slightly different technique, aptly named the Feed Extended Sample Transfer, due to the now permanently extended position of the drill. On Sol 2074, the Mars Reconnaissance Orbiter reports that the dust storm is growing significantly in size and intensity, covering the whole planet. This series of images shows how the storm has grown. This image shows what the face of the planet now looks like. You can see huge swirls of dust almost covering the entire planet. This is Curiosity's view of the storm. The image on the left was taken just 3 sols ago. Curiosity wants to celebrate a successful drill in its usual way, by taking a selfie. So it does, even if it is a little bit dusty out there. Luckily for Curiosity, it has a nuclear power source and doesn't rely on solar panels, unlike some of NASA's previous rovers. One such rover, Opportunity, is currently exploring the other side of the planet and has been doing so for the past 14 years. Unfortunately, this is the last picture NASA received from the Opportunity rover. After 14.5 years of continuous, faithful service, Opportunity stopped responding and went into hibernation. The dust covered its solar panels and the rover was unable to generate enough power to keep itself warm at night. Most of its components are thought to have been frozen and irreversibly damaged. It's unlikely the rover will ever come back online. As the storm begins to subside, the now lonely Curiosity rover takes another snap of the Duluth drill site. These two images show the site before and after the storm. Curiosity takes a quick picture of its drill to check for any damage from the new drilling method. All seems to be holding up well so far. Curiosity has an issue with its memory, stares at clouds in the sky, and witnesses a Martian eclipse. Curiosity is still in the lower Vera Rubin Ridge area at an important place called Pettigrove Point. The rover has been drilling at this spot for a long time, but has failed to reach the desired depth. Sadly, the rock is too hard to penetrate. Incidents like this cost a lot of time and energy. Going forward, the engineers at NASA decide to drill only at spots that meet two criteria. 1. Did the surface scratch the bristles of the dust remover tool? And 2. Are the calcium sulfate veins properly exposed after brushing? If it's a yes to both these questions, it's a strong signal for the rover to attempt a drill sample. The next day, on Sol 2122, the rover attempts again, this time at a place called Ailsa Craig. As a test, the dust removal tool tries to brush off the top sediments. Again, the drilling is a disaster. Despite the veins being somewhat exposed, the drill hole isn't deep enough for a full sample. This is now 2 unsuccessful drill attempts back to back. On Sol 2136, the team orders the rover to try drilling one last time at Pettigrove Point, at a site called Store. Store checks both the boxes. The brush bristles are slightly battered and the veins of the rock are adequately exposed. Finally, the rover succeeds in drilling a 46-millimeter deep hole. This hole has produced enough rock powder to be fed as a sample to the rover's onboard laboratory. Before packing up, Curiosity takes several observations with its ChemCam and MassCam and sends the data back to Earth for analysis. If the wind subsides, the rover will drop the samples onto its lab inlet. Pleased with its work around Vera Rubin Ridge, Curiosity takes a panorama. The sky is still hazy from the subsiding global dust storm, and a layer of dust can be seen on the rover itself. On Sol 2138, Curiosity captures an image that surprises the team. A small object is seen that looks completely different from the surrounding terrain. It's immediately labeled as foreign object debris and raises an alarm throughout the scientific community. While everyone speculates that this could be spacecraft debris or worse, a piece of Curiosity itself, the rover's ChemCam results, however, dismiss both. It is nothing but a thin flake of Martian rock. On Sol 2172, Curiosity suddenly stops sending a big chunk of its data to Earth. It can only send data when it is connected live to the Earth stations or the Mars orbiters. The team at NASA believes Curiosity has a problem with its memory. The rover normally stores data on board until it reconnects with Earth or Mars relay orbiters. Then it offloads all its precious stored data. The rover is currently failing to store anything. Due to the limited information coming from the rover, the team struggles to diagnose the issue. Luckily, Curiosity has 2 computers on board, Side A and Side B. However, if you remember, the team has already switched over to the B side due to corrupted memory on the A side, almost 2,000 sols ago. they make the drastic decision to return to the A side. It has much less memory than the B side had when it worked correctly, but it will help them to diagnose the issue faster and hopefully lead to an eventual return to the B side once a fix has been found. Curiosity resumes operations from its A-side computer, taking this panorama at a location known as Rock Hall. The rover also takes a selfie here after a successful drill sample. The area is still covered in dust after the global dust storm that incapacitated the Opportunity rover. Curiosity is now moving towards a clay-rich area that scientists have been hoping to see for the last 7 years. This visualization shows the proposed route for the rover. It will explore the aptly named clay-bearing unit before marching onwards and up Mount Sharp into the sulfate-bearing unit. The rover may eventually reach Gediz Vallis Channel, which has an uncanny resemblance to an ancient river. Curiosity looks toward the clay-bearing unit and sees waves in the foreground. Toward the left of the image is a portion of Vera Rubin Ridge. Scientists are trying to figure out why that ridge has resisted erosion, and yet the clay-bearing unit is much softer. The clay-bearing unit is an eroded valley between Vera Rubin Ridge and higher regions of Mount Sharp. The best explanation for why this valley has been eroded is some form of massive environmental change in the ancient past. As clay-bearing unit doesn't exactly roll off the tongue, the team at NASA renames the area Glen Torridon, after a narrow valley of the River Torridon in Scotland. Just as the rover is making good progress, it experiences a hard reset and automatically enters safe mode. The team at NASA has since isolated the memory problems on the B-side computer and so switched the rover over to that side once again. Curiosity steadily gets back to business by first observing a Martian eclipse. This is the moon Deimos, the smaller of the 2 Martian moons, passing in front of the Sun. On Sol 2356, the rover comes across an incredible patch of pebbles in Glen Torridon. These rocks look like they've possibly been rounded by water over a long period of time. Curiosity looks to the sky once again and is lucky enough to see the other Martian moon, Phobos, passing in front of the Sun. This series of images shows that Phobos is the larger of the 2 moons, at about 8 miles or 11 kilometers in diameter. The eclipse lasts about 35 seconds in real time. On Sol 2372, Curiosity gets its first taste of the clay-bearing unit at a site named Aberlady. The drilling is a total success. When looking at the before and after images, we can see that the drilled rock and terrain surrounding it appear to have moved when the drill was retracted. The rover looks up and sees Martian clouds. These are likely water ice clouds about 19 miles or 31 kilometers above the surface. These clouds are so high that they are still illuminated by the sun, even when it's night at Mars' surface. Scientists can watch when light leaves the clouds and use this information to infer their altitude. The rover takes another drill sample nearby, and you guessed it, takes a selfie in celebration of a successful drilling. On Sol 2407, a wheel check is initiated. Nothing surprising is found. The team's damage mitigation efforts, driving over softer terrain, seem to be working well. There is also a Plan B, in case the damaged wheels get in the way of the mission. The team would order the rover to scrape a wheel against a sharp rock, hacking off any bits that may damage some of the rover's more sensitive components. Curiosity views more clouds before setting off on a drive. The rover looks back at its tracks from its new location, known as Teal Ridge. By driving up the side of this ridge, the rover has access to an exposed unit of rocks. The rover takes a closer look at a site named Strathton. This boulder-sized rock has some interesting layering. An even closer look using the camera on the rover's arm shows the rock was created by the hardening of sediments deposited from both water and wind action. Curiosity takes a huge risk and climbs a very steep hill to get on top of a ridge, loses its balance, and takes a 1.8 billion pixel image. After taking 2 drill samples at a site known as Glen Etive, Curiosity takes a selfie. These annotations show the crater rim in the distance, as well as Vera Rubin Ridge. Curiosity has made a lot of progress through Glen Torridon, formerly known as the Clay-Bearing Unit. While the team at NASA celebrates Thanksgiving, they order the rover to complete its biggest panorama yet. This image contains nearly 1.8 billion pixels and is the most detailed image ever taken on another planet. The view looks over the whole Glen Torridon area, with Vera Rubin Ridge in the distance. We can see the rover's tracks through the clay-rich unit. As we zoom in on the formidable Mount Sharp, we can see a ridge. This is part of what's known as the Green Hue Pediment, and Curiosity will eventually have to climb up it in order to access higher layers on the mountainside. Curiosity makes good progress towards the Green Hue Pediment and currently sits on a small hill known as Western Butte. The plan for now is to simply drive up to the Green Hue Pediment to get a better look at the rocks there. This visualization shows the proposed route. The rover is currently on its way to touch the Green Hue Pediment before it will track back around into the clay-bearing unit once again, and then head to a more accessible route onto the Green Hue Pediment. The rover edges closer to the Green Hue Pediment. Geologists desperately want to gather data from the top of the structure, and so talks begin among engineers about a possible climb for Curiosity. Then, on Sol 2649, Curiosity wakes up with a bad attitude, quite literally. The rover is feeling dizzy and stops all operations. Just like us humans, Curiosity needs to have an awareness of itself relative to its environment. This data is normally stored in its memory and tracks things like the angle of the slope it sits on, how close its arm is to the ground, and if there are any big rocks nearby that could pose a hazard. The rover evaluates this data before engaging any motors to make sure that any movements can be performed safely. When the answer is no, the rover freezes in place and waits for the ground team to guide it on the next move. The team at NASA discovers a problem with Curiosity's attitude. The aerospace definition of attitude is how an object is placed in a 3D space. Basically, it's 3D orientation. So we can confidently say that Curiosity currently has a bad attitude. After the ground team informs Curiosity of its proper attitude, the journey continues. This map shows Curiosity's current location on Sol 2654. The rover is now very close to the overbearing Green Hue Pediment. To access data from the top of Green Hue, the rover will have to start climbing. Although this takes the rover on a little detour from its proposed route, the engineers agree that it's possible and worth the risk. Before making the climb, Curiosity uses its dust removal tool on a nearby rock. Multiple exposed mineral veins are present in the image. The team decides this area would make a good drill sample, so Curiosity drills another hole, this time on a rock feature called Hutton. The drilling goes ahead perfectly without any issues and produces gray amorphous tailings, enough for the sample inlet. If you've noticed, each time the rover drills, the colors of the tailings are different from the reddish surface. This is the first hole the rover drilled on Mars. Evidently, the tailings in this hole are reddish in color, similar to the interior of this drill hole at the Aberlady site in the clay-bearing unit. But here at Hutton, it's more grayish. Can you guess why? It's because oxygen reacted with iron in various parts of the rock differently. The tailings on the left are red because oxygen had the opportunity to react not only with the external rock surface, but also the interior. However, the image on the right tells a different story. The oxidation could not penetrate deeper into the rock in this case. This is particularly interesting for scientists because this kind of sedimentary rocks can house the traces of organic life in the past. Rocks preserve traces of ancient life better when they are not oxidized, because oxygen can break down the organic materials before they fossilize. Although the rover's drilling went well, it was far from elegant. The surface Curiosity sits on is so brittle that the rover's wheels crack the sedimentary rocks, turning them into detritus and powder. As it looks for a way up the Greenhue pediment, the rover catches an incredible close-up view of the ridge from below. These stratified layers are called nodules. These rocks are completely different from those of the clay-bearing unit, but somewhat similar to those we saw at Vera Rubin Ridge. Another sol on Mars, and another chance for Curiosity to take a selfie after its successful drill campaign at Hutton. From the data that Curiosity has collected so far, scientists are now convinced that Gale Crater was an oasis of water in the ancient past. Water ran through the Geddes Vallis Channel and spilled out into the clay-bearing unit. The Greenhue pediment resisted erosion and essentially became one big shoreline. On Sol 2693, Curiosity begins the climb up the Greenhue pediment. These raw images show the angle of the rover as it climbs. The incline is more than 30 degrees. It's considered a very risky move, but engineers are comforted by the fact that it's not the steepest climb a rover has performed on Mars. The Opportunity rover previously managed an even steeper climb, yet only by fractions of a degree. The rover quickly takes a drill sample from the top and looks toward Mount Sharp. There is no viable route from here, so the rover must descend the hill and get back on the official path. As the rover turns around to descend, it captures an incredible view from the top of the Greenhue pediment. In the distance, we can see the crater floor where Curiosity began this formidable journey. The rover is really making strides now. Curiosity continues to climb Mount Sharp, captures stunning images, takes more selfies, and makes good progress toward an ancient river channel. Curiosity is currently watching a dust devil from its position at a site known as Mary Anning. The dust devil is estimated to be about 16 feet or 5 meters wide and at least 164 feet or 50 meters tall. The frames in this sequence were captured over 4 minutes and 15 seconds. The team decides it's a good place to take some drill samples and orders the rover to go ahead. Curiosity drills 3 holes. This time lapse shows one of the drill attempts. In reality, it took the rover over 20 minutes to complete, using the feed extended drilling method, which still seems to be working well. Engineers responsible for the drilling can instantly tell that the rock is very soft based on the data from Curiosity's pressure sensors. It was so soft, in fact, that no percussion was required, only rotation from the drill. Curiosity celebrates in the usual way by taking a selfie. The rover will now spend a few sols putting together one of its most beautiful panoramas yet. In this image, some NASA scientists have described what they are seeing as a series of benches descending toward the crater floor in the distance. It's certainly a great view from here. The crater rim can be seen in the background. Curiosity turns around to continue the climb up Mount Sharp and comes across some interesting terrain. The closest outcrop is named Mont Mercou. Mount Sharp looms behind the other outcrops. While looking up, the rover captures a special type of cloud. These iridescent or mother-of-pearl clouds are sometimes spotted here on Earth at high latitudes, but are very rare. They radiate different colors and occur when clouds are very high in the atmosphere. This type of cloud might actually be more common on Mars due to the thin atmosphere. The rover approaches Mont Mercou and takes 2 mosaics from slightly different positions. When put together, these images create a 3D effect. The rover team spots some clouds behind Mont Mercure. They order Curiosity to take a few more images, which are then combined into a video sequence. Each frame of the sequence is made from 6 individual images. The rover takes a selfie near Mont Mercure after a successful drill campaign at a site named Nontron. It's named after a village in France because the area on Mars contains nontronite, a rare type of clay. The mineral was named after the area that it was first found, the French village Nontron. Curiosity spends a little more time observing clouds before setting off on a big drive. The team orders the rover to look toward a mountain in the distance, and they give it the name Rafael Navarro Mountain, after the astrobiologist Rafael Navarro Gonzalez, who worked on the mission until he passed away on January 6, 2021. This image shows the proposed route. Curiosity will pass alongside Rafael Navarro Mountain and then climb up onto the Green Hue pediment once again, before proceeding to the exciting Geddes Vallis Channel. Before doing that, Curiosity cannot resist climbing up on top of Mont Mercure and taking a panorama. The other side of Mont Mercure is relatively flat, so it was an easy drive for the rover. Still, the team at NASA won't allow the rover to get too close to the edge. After a long drive, Rafael Navarro Mountain comes into range. The rover will pass alongside this to access higher layers on Mount Sharp. Curiosity finds what looks like a Martian flower, finally reaches the start of the ancient river channel, and finds flaky rocks that look almost identical to rocks from streams or rivers here on Earth. After a short solar conjunction, the rover is back online and looking at some strange nodules on the ground. They are seen in abundance in this area, and the team orders Curiosity to crush some using its wheels. The crushing doesn't go entirely as planned, but reveals a shiny substance within the rock. The rocks seem to be getting harder than those seen in the clay-bearing unit. The rover is making good progress and coming up to a small passageway between the Green Hue pediment and another big outcrop. This is given the name Maria Gordon Notch. Curiosity took this image on Sol 3299, and it's been described as a picture postcard from Mars. It shows the path back down Mount Sharp, and Rafael Navarro Mountain could be seen on the right. Curiosity takes a selfie on the way to Maria Gordon Notch. The rover will now pass through. On the way through, the rover takes this incredible mosaic. This could be the best image ever taken on Mars. The overhanging ledge, the abundance of mineral veins, and some strange features all make this outcrop very interesting. Just look at this huge vein. It's resisted erosion while the surrounding rock has been slowly consumed by many years of water or wind action. At the top of the outcrop, there are some strange-looking nodules. Why is it that these nodules only appear on top of the structure? Could it be possible that the area was once a flowing river and those nodules couldn't form under the intense water pressure? Curiosity would love to stay here a little while longer, but it has a mountain to climb. On Sol 3325, more clouds are observed in the Martian sky. You can see their shadows rolling across the landscape. This series of images shows the view directly above the rover. On Sol 3396, Curiosity finds what some people are describing as a Martian flower. This strange object is smaller than a coin and is covered by a thick layer of Martian dust. At first glance, it looks like a plant. However, NASA believes this to simply be a cluster of mineral veins left over after the host rock completely eroded. We don't often see formations like this on Earth due to the higher gravity and denser atmosphere. On Sol 3415, Curiosity decides to once again climb up on top of the green hue pediment. The rover takes this mosaic at the top, but there's a problem. The top of green hue is littered with what scientists are calling gatorback rocks, which could damage Curiosity's wheels. The rover will have to get back down and find another way into the river channel. This view of green hue shows a sloping landscape in comparison to the level layers of the outcrops in the distance. Could green hue have been an ancient slope into water? The rover takes a closer look at these sharp rocks before descending once again. This is the second time the rover has climbed and then had to descend from the green hue pediment. On Sol 3492, the rover comes across some flaky rocks that look almost identical to some rocks back here on Earth created by streams and rivers. On its 10th birthday, the rover sits here at the start of the Geddes Vallis Channel. Its journey has been incredible. Curiosity has driven 17 miles or 28 kilometers. Curiosity has acquired almost 500,000 images, transmitted 31 terabytes of data, climbed more than 2,000 feet or 612 meters, and its findings have given way to 883 academic papers. The rover has proved beyond all reasonable doubt that water was once prevalent on Mars, and not just acidic water, but fresh water suitable for the creation of life as we know it. Curiosity has well outlasted its primary mission and will continue to roam the Martian surface for many years to come, until the failing of its final instrument. A newer generation of rover is already on the Martian surface, called Perseverance, doing everything that Curiosity could and more. The inclusion of a microphone for capturing Martian sounds, a helicopter to scout ahead, and higher quality cameras all make Perseverance the superior mission. But does it have the curiosity to continue? Click here to see our series on the Perseverance rover, to see if it will in fact outlast Curiosity. Thanks for watching Elder Fox. Please share this series with anyone who doubts that Mars once had liquid water.